So, next interview with Andrew Grimshaw. You're a former professor for computer science. You founded a couple of startups.
Yeah, right.
You're a successful entrepreneur, and you are from the US.
Yeah,
So,
that's
my
correct.
first question would be, Andrew, what can we in Germany, let's talk about policymakers first,
Okay.
learn from the US in terms of AI and especially regulations? Do you need them or don't you need them?
Right, so the first thing I want to say is I'm not speaking as a representative of the University of Virginia or Lancium, where I used to work. But with respect to AI and large-scale AI data centers, what I would say from my experience with Lancium, I need to give you a little background on that first. So right now in the United States, the projections are as AI will use 94 gigawatts of power in the next 7 years. That's a lot of additional power capacity. So our company had 5 gigawatts of power in West Texas, and so we started out doing one thing, ChatGPT happened, and now we're providing essentially power for large AI data centers. And one of the things that has happened in the United States in the last year and a half, as this has all been sort of unfolding, is even though we have a lot of power in the United States, and we have a lot of excess power in Texas, not excess, but a lot of power to spare, let's say, in Texas, is that when you try to drop 14 or 15 gigawatts of power in 2 years, it puts a lot of strain on the system. And one of the things you need to know about the electricity grid is it always has to remain balanced or bad things happen. And traditionally, the generators were much larger than the loads. But when you have a 1 or 2 gigawatt data center in West Texas, it's much bigger than any of the generators in the state. And so it changes the dynamics of how do you make sure everything is going to be okay. So a little over a year ago, Texas, which is not known for being heavy on regulation, made a new regulatory change that basically says if you're going to add a large load to the grid, it has to be controllable. And the reason is we always have to balance the grid. And if something goes wrong on the grid, like a transformer blows, or a power line goes, and I'm talking big power lines goes down, you need to be able to either rapidly inject additional generation capacity or rapidly drop load. And you have these giant loads sitting there, and so what they're saying is if you want to do a connection, you have to be able to drop your load quickly. Because what will happen if you can't bring the grid back into balance in 15 seconds, that's not very long, you can have what are called cascading blackouts.
Okay.
And as an example of how things can go wrong, you can just look at what happened in Spain in April. Things can go south really fast. And so what we're learning in the United States is that you need to have these new loads be controllable. Otherwise, you can't guarantee stability of the grid, and nobody wants there to be a blackout in Texas or Germany or the northeastern United States. So that's the thing that I'm trying to bring the message here to is that the German electricity markets are going to need some changes to incentivize good behavior. That's traditionally the role of government, is to incentivize good behavior. And then secondly, some of the rules will have to change. You don't have any gigawatt scale data centers yet, but I would argue you shouldn't have any unless you tell them you're going to have a controllable load. How they make it controllable is their problem. There's several technical ways to doing that, but they need to do that and not just sit there and say, we're going to use power and watch the system fail.
I think this issue isn't talked enough in Germany. So I think everyone knows, okay, perhaps if we use more and more AI in all of our Mittelstand companies and the large corporations, we need a little bit more energy, but we have rising energy costs in Germany. And I think there are a lot of smart solutions what AI can be implemented for, but not so many solutions as how we address the energy and electricity problem, right?
You have to keep it balanced. And actually, your base energy wholesale prices aren't that different than the rest of the world. Germany adds a lot of other things onto that, which makes it a little bit different. But you do need to ensure stability. I mean, if you look at the projections, 2.5 years ago, they said there'll be $1 trillion spent on AI data centers by 2030. The consensus opinion amongst the investment banks and everybody right now is closer to $7 trillion. That's a lot of money. And that's a lot of hardware, and it's going to consume a lot of electricity. And so you know, if Germany wants to play in that game, and they may not want to play in that game, right? Then they're going to have to restructure some of their electrical markets in order to make the power available. And by the way, it's not just the amount of power, it's the transmission lines. It's another place where we have major problems in the United States. I'm going to talk about that in a little bit. But Germany has the problems, just a much more difficult environment to put up power lines, let me put it that way.
Looking at AI developments in Germany, what are some chances you think Germany has where it has perhaps even an advantage compared to the US? In terms of AI, perhaps implementation? Or are there only disadvantages in Germany?
No, I don't think there's only disadvantages. I don't think I'm qualified to answer that question, is what it is.
Right.
I don't like to just make stuff up.
Okay.
So, I mean, you have a parliamentary system. That's an advantage over the United States, because if the government can actually make up its mind, it can do something, right? We don't have that in the United States. So there are advantages to being in a parliamentary system. In terms of AI, the other thing to keep in mind is Germany, oftentimes people think the government is going to do everything. What I've learned is even in the United States, the amount of money the government has to bring to AI is peanuts compared to what industry has. So I think Germany has a lot of large industries that can fund that sort of work. The question is, will they? And that's, I don't know the answer to that.
From an academic perspective, you have taught computer science for a couple of years, back in the days even. How does this university subject need to change to adapt to all the new developments in the field of AI?
So the first thing I want to say is computer science, sort of starts at digital logic and goes up to what we call the application layer. And the application layer, AI is an application layer thing. And the really important thing, a lot of computer science students today just want to jump straight to the application layer and not understand the underlying fundamentals. The problem with doing that is that you can end up doing things at the application layer that are extremely expensive at the hardware layer in terms of performance or energy consumption or something like that. So what I would tell students is focus on the fundamentals, because once you know the fundamentals, any application layer thing is pretty simple. And also, don't just work in languages like Python, which are from a saying a high performance Python program is an oxymoron. Python is hideously inefficient use of the hardware. Don't do it. And that really means you need to understand all the layers and make sure that you properly write your code so that it's fast. Performance matters. I've had people, a colleague who said, well, it doesn't matter if the code is slow, we'll just get another VM and run 2 copies of it. And it's like, okay, you're obviously not paying for these virtual machines, right? A, and B, it's not just the money, it's the electricity, and it's the CO2, and it's all of that stuff. So just keep your eye on performance, because performance matters.
Andrew, thank you very much for your perspective, and good luck to you going forward.
Thank you very much.